Hello, everybody. Can you hear me? Yeah. Oh, okay, great. Yeah, so this is a bit unexpected for me too. I spent yesterday most of the time explaining to everybody why I don't have a release for Silly Venture this year. So I thought it would be the easiest way to just go on stage and give my excuse publicly. So we have some feedback. Okay, thanks. Yeah, so seriously, what I have been doing in the past 1.5 years was not coding on the Atari, it was working on the tools to work on the PC to create tools, to create games and demos on the Atari. So I focus on enabling people to write stuff for the Atari in an environment that they know, so on their PC or on their Mac, and to lower the entry barrier for them to start coding. Yeah? Most of the time, coding on the Atari means working in assembly. That's hard. And at least the tools to do that should be easy to install, easy to use, and be well documented. So this morning we heard Katz with his talk about the Grell book and the new book from Kamil about assembly programming. So if you follow his advice and your wife gives you this assembly book for Christmas, then the next thing that you need is my IDE, so you can actually type in that assembly and try it out. So, the IDE exists actually since 2009, and of course a lot has changed since then. So the first thing I want to show you is how to install the IDE. That's the first part of what I'm going to show. And the second part is that we are now extending from assembly to Pascal, to Mad Pascal to be exact, which is a cross-compiler that allows you to use standard Pascal to create really performant and efficient code on the Atari 8-bit. So, what is WUDSN? It's easy, it's a very selective term. If you just enter it in Google, you will find my website. And on that website, besides my demos, you find all the details about the IDE, what it is, and how to use it. If you want to install it, in the past it was a bit cumbersome. So you could either follow the manual process, which means you need to install the right version of Eclipse. You install my Eclipse extension, so it learns 6502 assembly and what a PokeTune is and what our graphics formats are. So this is not just assembly. So this IDE really brings together all the assets like RMT files, and you can play them in the IDE, so you don't need external tools. Then you need the assemblers. So the IDE itself does not assemble, but it uses the existing assemblers that are around for several reasons. First of all, making the IDE is a lifetime project, and I only have one life, so I have to focus on that. Instead, we have developers for all these compilers and assemblers that are their lifetime projects, and they keep them alive and they keep them updated. Equally, we have the emulation, so we mainly have Altera on Windows, or we have Atari 800, which is cross-platform, and we have Atari 800 Mac X on the macOS platforms. And each of these projects, there is one person behind it, and it keeps it alive because it's their pet. So my aim was to bring together all these people and to provide the linking piece between the editor and the assembler and the emulation, so that you as the individual developer, you don't have to care about the different pieces in this chain. It goes so far that probably this is the only 8-bit IDE where you can set a breakpoint in the source code and your emulator will stop at that point. Yeah, so this was really from the IDE to the assembler to Altera. It was a project with all three of us to make that work. And of course, the performance of an external assembler and an external emulator is much better than if I had written one of my own. Then the next thing, if you have all these tools, then you need to somehow get started. An IDE is not worth much if you don't have a simple example from which you can start to understand, this is Hello World, this is how I get my Atari Rainbow. on the screen, and from there you can start typing around and playing around. So you also need the sample projects. And sample projects are nice, but you also need documentation. Also with the IDE come two playlists on YouTube. One where I explain how to use the IDE, and the second one where I explain how to do assembly on the Atari 8-bit. It's always short videos, about 10 minutes, so you can have one video one day and play with it. Okay, and when I created this, I choose Java, so it's available on all platforms. But the price is that you have these different steps. Yeah, so there are really these building blocks: Eclipse, my IDE, the assemblers, the emulators, and the sample files. And now I have this very excellent description of what you should all do if you want to get it running, but of course that's still error prone, and then you move to a different machine, you have to do it again. Recently everybody had to move to Windows 11 and they had to do it again, what they did 10 years ago. And unfortunately I found out I have not created a recent installation video, so people are using the video from 2009 and they're of course failing. So that's why I do this presentation here, to show you how easy it is nowadays, because you don't need to go through this description anymore. I have turned this description on this page into code. Which means that if you go to the installer, which is on GitHub, then you simply find a single execution file there. Yeah, there's one XEX. And now I will be doing a live test. I hope it works. So I have created an empty silly venture folder on my hard drive. Now I go here and I save the file. And I just save it to that folder. So it's a very small file because it's just one XEX. And what it does now, when I click this file, it will extract itself to a batch script. And that batch script, step by step, does the steps that are on my page. So it will download all the required files, it will put them into the right folders, it will unpack them, install them, and so on. So I click this file. Then of course Windows complains because I have no certificate, never mind. So we run it anyway. And now the installation process starts. So you see it's writing a log and it says installing tools. So the first thing it does, it will now download all the Eclipse and tools and everything that I provide on my website. I provide them on my website, so I have a stable version that doesn't break just because Eclipse pushes out something new. And now I hope the network is fast enough. So, yeah, this will now, not sure how many people here are on the network because this is not small. Yeah, it's downloading the tools. The next thing that it will do is will unpack them. Now I see the tools main is downloaded. And it's unpacking, so the zip is unpacked. And if I go here, now I see there is a tools folder created. In these tools, you now find the different assemblers that are supported. We find tools for ATR management. We find Altira, which is included as a standard emulator. The others are not included because it would be too large. And then we have the actual IDE, where there is the Eclipse version. This is the new one. That's what I'm talking about later. That's the Mad Pascal, currently still rudimentary integration. And when I go here, let's see what it's doing. Okay, it's installing the tools, it's installing Eclipse, it's installing the right version of Java. And now it is starting Eclipse to put my plugin into Eclipse. And ultimately, this will start, when this starts, let me see if we have everything together. No, not yet. Yeah. So this is a feature. Feature is an extension in Eclipse that now teaches it what an assembly file is and how to deal with it. Okay, so maybe while this is running, any questions so far? Why Eclipse? Well, I started coding in Java in the 19s. It started with me as a young guy lying in the swimming pool, reading the RFC specification of the first Java bytecode, and I said, wow, that's cool, it will run on all machines. And I turned that into my job, and when I started in 2001 Java coding, Eclipse was a standard. Yeah, so I know it very well. And if you know Eclipse from your business work, forget it. This is not the Eclipse that you know. Eclipse is in fact a framework to write IDEs. And if people use Eclipse at work, wherever, they do not use Eclipse. They use normally all the additional features for Java development, web development, and it's bloated. So it's 200 something megabyte, and what you think you get is an editor. So this is really just the core of Eclipse. It's called the Eclipse Platform Runtime. So you have a folder structure, you have a workspace, and that's it. Yeah, and all the other entities from your menus, they are not there. So it's really a minimal Eclipse. And as an Atari coder, for you, it doesn't make a difference. It just is an editor. Yeah, ignore that it's Eclipse. It's just a foundation that enables me to write this plugin. Yeah, and of course, I invested now 15 years. There is no point for me to switch to anything just because it's now hipper. In the end, it doesn't make a difference. This is really for the people that are not native Atari coders for the past 20 years. Yeah? If you have been a coder in the past 20 years on the Atari, you have your own tool chain, you will be using Vim scripts, whatever. Yeah, that's not this. If you have that and you create Atari stuff that's with it, that's great. Yeah, but if you are somebody who wanted always to write something on the Atari, but you didn't dare or didn't know how, then this is what you can do. You download this exe and you can just get started. Okay, this takes a bit longer than expected. I hope it completes. Well, let me see if there are any pop-ups in the background. No. No, this is just now because of the network maybe. That this is initially takes some time. Okay, other questions? No? Okay, then while this is running, I will start in parallel with the second topic. The second topic is Mad Pascal. When the IDE will start, I will import my example projects, and one of them that was added 2 or 3 years ago is a Pascal project. Now you may think, why would anybody on the world use a Pascal compiler to do something on the Atari 8-bit? Now this has run through. So now I here can, in my IDE, yeah, this is a performance optimization. Eclipse contains a lot of files. Windows Defender is dumb. It tries to scan thousands of files every time you start the app. So here I say I don't want Windows Defender to scan my Eclipse every time because I know it is Eclipse. Okay, that happens only one time, and then also only one time you have to choose which platform you want to develop for. So here you can choose the different platforms. So everything that is MOS65 or 2 based can essentially be used. So here I'm choosing, of course, the Atari 8-bit sample projects. And now we have a hello world. And I can just click that button and it works. Yeah, so you download the exe, you wait a little, you choose Atari, and then you have working code. And then now we are back in the 80s, so if you think you want to modify that code because stable rasters don't look good, then you make them moving rasters by playing around with the code. Yeah, so from 0 to everything with just one click. Here you also have the sample files for my assembly course that starts with what is an executable, how do I put something on the screen, how can I change a character. And for each of these, there is accompanying video. If you go to the help, then in the IDE, in help indexing might now take a minute. Oh no. So there is the help index that explains the different assemblers that are supported, and also Pascal. And for the Atari 8-bit, you have references to the NTIC and POKI registers. And somewhere there are also the tutorials. There they are. Yeah, so here are also the links to the video tutorials. Yeah, looks like YouTube doesn't embed. So there is a total of 15 tutorial videos how to learn assembly on the Atari. And yeah, with this, you're essentially ready for Atari development. As said, this is not only For assembly, it also includes sound and graphics conversion and similar things. And now we come to the second part of what I want to present. Some years back, in 2020, the developer of the Mad Pascal Mad Assembler, which is the main assembler supported by the IDE, he said, okay, now my assembler is mature. The assembler could actually do a software stack and calling procedures with parameters, and they are turned into LDA, STA before the call. And when this was all ready, Tebe decided, I need to create a higher level language on top of it. Yeah, so assembly is great, but it's a lot of code, sometimes for very simple things. So what he did is he picked an existing assembler that is an PC assembler for x86 assembly, and essentially he exchanged the backend. So he took the existing assembler, and instead of creating x65 assembly, it started creating 6502 assembly that looks like x65 assembly. Yeah, so for all the registers, he defined the location in the 0 page and tried to make it work somehow. And he worked several years on this until he finally put the whole thing on GitHub. So if I search for Mad Pascal, yeah. So if I search for Mad Pascal in GitHub, then I will find the GitHub repository from Tebe, the current one. There are two repositories, one for the actual code and the other one for the documentation. This is the documentation of Mad Pascal. It's essentially a almost 100% compliant free Pascal compiler. Yeah, so what we're trying to do here is we're trying to not create something that's Atari specific, but we want to use as much as possible of the existing free Pascal code base, which also means that all the documentation that you will find for the standard libraries and everything, it is there and it's just there, it just works. This is the specific documentation that describes the more specific features of Mad Pascal or the restrictions, things that do not work. So we are now in version, I think it was 1.6.3. And now I show you what... okay, let's do two things. First, let's go back to my IDE and set what we have here. So here I have this Pascal folder with the first example. The first example is, okay, it's a hello world, but it's not actually only printing hello world. It also uses some DLIs and it wants to change some color registers here. Yeah, so Atari specific stuff that you normally would only do in assembly. And what we see here is we declare a program, then we can have variables, and these variables can be like labels for addresses in the memory location. I can write a procedure and I can declare this procedure an assembler procedure that it means an interrupt. Yeah, and with this, I tell the assembler, the compiler, that it should end the procedure with an RTI and not with an RTS. Inside that procedure, I can write assembly or I can write Pascal, and you will later see that the translation is really one-to-one. Then this is the main. Here is a hello world output. Then I show here setting some vectors, yeah, like the Atari operating system. You set the vector for the vertical blank if you like. And then we do something in the main loop. How do I run this now? How do I compile this? Here are two currently batch files. That's what I want to make better in the future. For this project, there is the example batch file. And what does it do? It changes to the current directory and it calls the other batch file and says, please compile this. And this is the reusable part. Yeah, so this may look complex, but what in the end it does is it runs two programs. First, it runs Mad Pascal, and Mad Pascal transpiles the Pascal file into 6502 assembly. And then in a second step, the existing Mad assembler assembles the assembly file to an executable. So how do I run this? I can run this by clicking it in the Explorer, or I can run this as a batch file. No. No. Where is my... So I want to open this with the system editor. So it now runs this batch file, and there we are. Yeah, so it now created from the Pascal the executable, and it started Altera already. We can see here it printed something in Hello World. We can see here the color is changing because I use a DLI to change the color in the middle of the screen. And the rest of the colors here are, if you remember, they are these assignments where I essentially say color, background color is 14, background color is 0, loop forever. Yeah, and this, if you are an experienced coder, it shows you how many cycles there are between these changes. So this really translated into LDA, STA, jump. Okay, as said, it was a two-step process. So if I refresh what we have in the folder. No, come on. Edit. Function keys. Okay, so what happened? The batch script took the Pascal file and it translated it into this assembly file. This assembly file only contains the actually used stuff from the libraries. Of course, there is a huge set of libraries with Pascal that contains all the I/O, all the basic functions. The Mad Pascal compiler will only include the actually used parts into your assembly code. Yeah, so here we see now the assembly code, and then Mads was used to create the executable. Yeah, and now remember we have been compiling a high-level language, and this is the result. Yeah, so there is no runtime overhead, there is nothing. This is really minimal assembly that you get from this. This Hello World example with pointers and everything it compiles to something that is not even 256 bytes. Okay. Well, this was a very simple example, but it shows how the process is. So first Pascal to assembly, then assembly to executable. Then how is the Mad Pascal structured and what can I do with this? So this was a simple example, and as I said, our aim is to make it platform agnostic. And that means two things. First, it means that you can not only compile for an executable on the Atari, you can equally compile for an executable on the C64 or on the C16 or any other 6502 machine. You can even compile so it later runs not from a file but from a disk or from a cartridge, even from a banked cartridge. Yeah, these are features that are built into the compiler itself. Important to understand how something works are always examples. So here we have the folder with the examples. There are around 700 examples from demos, algorithms, whatever. And what I do now is I will show you how I integrated it into my Windows environment. So let's take here one of these examples and show you the strength of why Pascal makes sense, because it allows you prototyping on the PC for everything, and only for the critical parts you need to do something Atari specific. So here I have Pascal files like this one. Yeah, so it's simple Pascal file, some loop that draws some pixels. And what I can do now here is, from my context menu, I can run this with free Pascal compiler. So it runs it with free Pascal compiler, and that's my executable application running on the PC. And I can use the same source code, and I send it to Mad Pascal. And it compiles it, and it runs it in Altera, because the same code now compiles for the Atari. Yeah, of course there are limitations. If I want to use DLIs and so on, but since you can use conditional compiling, you can have the same source code and one version that runs on the PC and one version that runs on the Atari directly. So there are a lot of A lot of examples, there are demos, there are games. If you have done something and you want to contribute it to the repository, please do so. Every piece of code that we get is also a test for us. Okay, and now I'm winding back in time to show you what we did. So I said this talk is about why haven't I done something? I actually have done something, but it's on this hard disk. And so 5 years ago, when Tebe put this all online, this is how the structure of the Mad Pascal compiler itself was. What do we have here? We have the actual source code of Mad Pascal. And it's 931K, and how it is written in Pascal itself. Yeah, so this is a Pascal compiler, is a Pascal compiler itself, a Pascal program itself, just like GCC is written in C. This Pascal compiler is written in Pascal. So and now I want guesses. How many lines of code do you think are in this 931 single file? 40,000. We have dentifrice saying 40,000. Other guesses? Somebody raising? 50? 50,000? Okay. So when I joined the project, this is a single file. And I open it with Lazarus. And I scroll to the button, and it's 31,000 lines of code. Quite close. Congratulations. And as you can imagine, if you have a single file, a single program, everything is a global variable. Yeah, and this is the legacy of something that started as a PC compiler. Then, of course, this code may work, but the probability that if you change a single line, it breaks completely, it's 100%. Yeah? Tebe is a good coder, so it didn't break 100% of the time, but it broke often. And progress was not so fast. But because he put it online, over time people joined the project. So what we have is, we have Tebe, who is mainly into the language and the optimization part. We have Bocciano, who is providing additional libraries above the Pascal layer, so that you can have game-oriented programming and you have support in the libraries. Then we have Zibiti, who is into the Linux part and testability and test automation. So there are several people with their special focus and interest that contribute to the project. Okay, what else do we have in that folder? So we have the Pascal compiler itself. We have the base folder with the platform specifics. At that time, there was only Atari. Yeah, and if you look into the new folder, you will see different platforms. Then we have the libraries. This is the real reuse. Yeah, this is where Pascal plays its strength, that you don't need to reinvent the wheel. Reuse in assembly is extremely hard because the abstraction level is not right. Here I can reuse any library into my code, and because of the way Mad Pascal works, it will not bloat my result. Only the really used parts of every library will be in, because these libraries are themselves just source code. Yeah, so this is not linked or something like you may know it from libraries on your PC. These libraries themselves are source code, and what makes them libraries, oh, not this one, yes. What makes them library is that they start with unit and not with program. Yeah, so a program is an executable that you can start, and the unit is a reusable block that you can use in every program. Okay, then besides this standard library, we have here the B-libs, the Bocciano libs, and later you will see more of them. We have a template to create a new project. We have the documentation that is nowadays an own repository. And essentially that's it. Oh, we have the samples, which here were a zip file. Okay, and now if we move forward, what has happened in these 5 years? And I can show that best if I go into the source code. So what has happened? So the first thing you see is there is a Git folder. Why? Because now everything is on GitHub. All this is public, you can download it, you can modify it, you can play around with the sources. Then we have introduced, to prevent regressions, we have introduced automated tests when we push to GitHub. So before we send something to GitHub, there are GitHub actions running that are in this test folder. And what they really do is they take a defined set of our tests, they compile them, they run them with a 6502 emulator, and they make sure that everything is as it should be. So we don't break our own stuff unintentionally. So besides the Bocciano libs, there were additional libs added. If I look into the base folder, you see that this is now not only Atari, this is now structured along the supported platforms, and there are more platforms added over time. And in these sample folders, what you will find is you will find almost 700 sample programs that you can just click and run, and play around with them. Okay, the actual source code is now no longer a single file. How much was it? Let me see. So version 1.6 was 931K of source. The current version, or to be released version 1.75, if I take all of this, yeah, just a rough estimate, how much is it? Okay. So this is now 1.3 megabytes, so 25% more. Well, not actually. When Tebe did this, it was a one-to-one translation and it worked, but of course it was slow. Yeah, because the resulting code, it contains a lot of repetitive things because it was done by a compiler. And what Tebe did is he added an additional optimization stage that now takes the assembly output and rewrites the output in a way that you would do it as a human developer, because you know that on the 6502 you can write this shorter, you can use the index, and so on. And when I took over the project, what you also see is there is not a single file. Yeah, so now we have here about 30 files. Yeah, that was my main job, to split up the project into smaller chunks so that you can have unit tests, that we know what this file does and declare it as done so we don't touch it anymore, and cut this into smaller pieces that are more manageable. And in parallel, Tebe took care of the performance. And when I was done with that, I realized, I forgot one folder. And then I looked into that folder and I said, okay, there are some more files that I need to rework. And then I found there is even one more folder. And when I opened that folder, I was blown away, because that folder contains a total of So these are 1.6 megabyte of source code, and this source code is only the source code to optimize the results. Yeah, so Tebe actually wrote more code to optimize the final results than the whole compiler, even with all my refactoring, is worthwhile. Yeah, and that's the complete knowledge of 30 years of 6502 development. And that's why the result of this is typically not distinguishable from something that you really wrote manually. Yeah, and the compiler can do certain optimizations much better than you can. Okay, so yeah, that's the current state of the project, and I wanted to show why we are now confident that things will get better. So on the one hand, I showed you that we split this one huge file with 30,000 lines of code. We split it into smaller chunks. And what that allows is that we have now also tests for these smaller chunks. I'm using here the Lazarus IDE, and we have 3 projects that are in the projects folder. So the first project, that's not very sexy, but it is the unit tests project. And what that does is, for all the units that we refactored out of the main code, it contains test routines, and I can just run it. And if I do that, then it tells me main test complete. Yeah, and I know I'm fine. Yeah, don't be confused about this error message, because it's a test if file not found really fails if the file is not there, so that's intentional. So the next step is that during development, I want to be able to debug Mad Pascal. That's what the main Mad Pascal project is for. So I can use the test Mad Pascal, and I can run it here. And now it does the same as if I run it from the command line or from a script. Yeah, it takes that and creates the corresponding output. this I use if I change a feature, and once I'm done with something, the most important thing is not that my new code works, but that we have not broken any of the other 1 million lines of code and all the test examples. Yeah, thanks to Microsoft, I had to buy a new machine to run Windows 11. And when I did that, I was in the midst of the Mad Pascal project, so I said, damn it, I will enter some more euros and I will buy a machine that has as many cores as I can. Because what I did is, I created now a third program, that's a kind of a meta project, and what that program does is, it's called Make Mad Pascal. No, that's a wrong. So this is Make Mad Pascal, and the purpose of Make Mad Pascal is take all the examples that we have in that folder, so scan the folder, find out which is an executable, find out which libraries it needs, and then it really compiles all 700 programs that we have, once with the old version and once with the new version. And then it makes a comparison to find out, to ensure that really we have zero regression in what we do here. So if I go here to the projects folder, then I now CD projects. So Mad Pascal itself, this is now my test version, so this is test Mad Pascal. So what does it take as an input? It takes the path to where the libraries are. You can define symbols if you want to do conditional assembly. You specify the target platform where the default is Atari. Then you can specify the CPU mode, because sometimes you want to compile something for 16-bit machines or without illegal opcodes, so you can specify that. You say the base address where you want the code to start. If you don't specify it, it's 2000. And you can also say where the data should be starting, where your software stack should be, and where the zero page should be. So besides the Mad Pascal runtime requires 26 bytes on the zero page, the rest of the zero page is free for you. And then you specify the name of the output file that it should do. That's what Mad Pascal does, and then I have my Make Mad Pascal. So, and Make Mad Pascal, if I run it without parameters, is it would default it, and here you see that it's trying to detect the two versions that I want to compare. So here I have the current Mad Pascal version, then I have the reference version, which is our baseline for the results. Then I can specify the input folder for the samples, and then I can also specify a filter, because sometimes maybe I don't want to compile 700 programs, just one. And if I run this now with a single file, then it now tells me that the executable does not exist because I entered clean. So I first have to go back once. So source. So I compile now Mad Pascal itself. So there I have on my machine free Pascal compiler installed, so I can compile Mad Pascal by itself, Mad Pascal itself. So now it's compiling Mad Pascal, and then it does a regression test. So first it compiles our sample source with the old version of Mad Pascal, 1.7.4, and now it compiles it with the new version. And here you also see what now the result of all this refactoring is. So to be honest, Tepe didn't want to switch to my version when I was done, because my version was only half as fast as the initial version. And he said, no, we're not doing this, because it's Tepe. He spent 1.6 megabytes on optimization, and I come and I make his project half as fast. Okay, that's not acceptable. But that was just the beginning, because after the refactoring we had now the chance to do caching, to use modern data structures, and instead of 2 loops, use references. So the result is that after 3 weeks of additional work, we actually could double the speed of the compilation. So instead of half as fast, it's now twice as fast. And okay, now I have the original and I have the reference, and I can run the comparison run. So what it now does is it compiles the same thing, once with the original, once with the new version, and then it tells me if there were any differences. Yeah, and it creates a log of these differences, and here the difference is that the reference file failed, so not my new version failed, but the reference file failed. Why is that? That is because the, go here. Why did the reference file fail? Well, we are also continuing to develop these internal libraries. So we're not always changing the compiler, sometimes we're changing the libraries, and then the compiler is no longer compatible with the libraries, and then we have to rebase. Okay, but what is the result of this test comparison? We get 3 files. We get the compile result of the new version. We get the compile the compile result of the new version, which is just fine. Then we get the compile result of the reference version, which was a failure. And then I get a comparison result for all of this. And now I go to the... So, and now we'll show you why I bought this 14-core machine. Because if I want to make the final test, then I have one script here, and if I run this script, it will now scan, and it will scan and find 741 source files to compile, out of which 620 are actual executables. And now it will use all the available threads on my machine to compile all this in parallel, once with the old version, once with the new version, and then create the diff file. Yeah, and with this, I hope that we can make it more stable, we can make it testable, and provide the new version soon. It will functionally not really be different, so if you want to start, you don't have to wait for this.
I'm sorry, excuse me. The competition have been moved to 6:30 p.m. The kompo zostało przesunięte na 18:30.
I hope not because of me. I bought a 14-core machine. It just takes minutes.
No. You're okay.
Okay. Yeah, and actually that's the end of what I wanted to show. So yeah, that's why I have spent most of the time on this, because I want to enable people and my IDE to use Pascal in future, so you can use assembly only when it's really required. Any questions? Yes, Pepe? Wait.
I have a question about debugging program written in Mad Pascal directly into Altira. There is hard to debug program directly into Altira because it's expanded to the into the assembler, and it is possible in WUDSN sorry, to debug with the source code and the Altira results both and step by step.
So yeah, he brought up the point, how about debugging? Yeah, and it's already hard if you really have assembly. What you can do in the IDE is, as I said, this is a two-step process. So first it creates from Pascal an assembly file, and then you assemble the assembly. What works in WUDSN, and I can show it maybe here, is that in WUDSN, if you have an assembly file, then you can pin a breakpoint here. And then Altira will stop at that point. Yeah, so on the assembly level, the breakpoints work. The problem is a bit that in the assembly you don't see which original line of code it was in Pascal. Yeah, and that's the step that I want to add later on. So once this is all done, I want to make a version where you can say that you want additional debugging output in the assembly, so that you can see, this assembly line, it corresponds to the following line in the original source code. And with Altira, maybe we can also get to the point where you can set a breakpoint and it will stop at that logical line in the code, provided the optimization hasn't removed it. Yeah, so that's a goal, also to make it simpler, that you can set a breakpoint in the IDE and you don't have to fiddle around. Okay, yeah, if there are no more questions, I think I'm ready for a drink now. Thank you for your listening, thank you for participation, and see you next Silly Venture.
Question?